Hey, what's going on, guys? So today we're going to be looking at Unit 3, first day Unit 3, all right, cubes and cube roots, all right? So we've talked about squares and square roots and perfect squares, okay? Here is what this looks like. This is a square root, okay? Your square root normally won't have anything here. We just assumed that's a square root, okay? I'll just abbreviate here. What we're going to be looking at is a cube root. So how do you know the difference with a cube root? Your cube root will look like this. You're going to have a little 3 right here. It's like an exponent, but it's a little 3 right here, okay? This is telling you to find the cube root, okay? So you'll have a little 3 right here that identifies your cube root. A square root should have a 2 there. We don't put it there because we automatically assume that's a square root, okay? So what we're going to do is we're going to start talking about perfect cubes, okay, and their roots. All right, so we're going to make us a chart. So what I want you guys to do is also to kind of make this chart with me. Let me get some colors here so we can have these all separated so we don't get them mixed up. All right, so first we're going to list the roots. All right, so we'd have 1 cube, 2 cubed, 3 cubed, or to the third power, 4 cubed, 5 cubed, 6 cubed, 7 cubed, 8 cubed, 9 cubed, and 10 cubed. We'll just do the first 10, okay? So what this looks like when we say something is cubed, this is going to be 1 times 1 times 1, all right? And what that's going to equal is 1. These are our perfect cubes. Just like we have perfect squares, we have perfect cubes. All right, so that's going to be 1. The next one, obviously, is going to be 2 times 2 times 2, and 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. Our next one, 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. And then we have 4 times 4 times 4. 4 times 4 is 16. 16 times 4 is 64. 5 times 5 times 5. Whoa, easy there. 5 times 5 is 25. 25 times 5 is 125. Our next one, we have 6 times 6 times 6. And 6 times 6 is 36. 36 times 6 is 216. Our next one, 7 times 7 times 7. 7 times 7 is 49. And 49 times 7, 343. Our next one, 8 times 8 times 8. 8 times 8 is 64. And 64 times 8 is 512. Next, 9 times 9 times 9. 9 times 9 is 81. And 81 times 9 is 729. And last but not least, 10 times 10 times 10. 10 times 10 is 100. And 100 times 10 is 1,000. So that's kind of our process there, all right, on how our cube roots and our roots work, okay? So 1 cube, of course, anything to the cube is that number times itself 3 times. And these are your first 10 perfect cubes, okay? So let's look at our first example on how this would look. Obviously, we know what this would look like, okay? So let's say if we ask for the cube root of 8, okay? This is a cube. So that's asking what number times itself 3 times will give me this number. 8 is a perfect cube. I know if I work it backwards, my answer is 2. Okay. Look at another one here. What is the cube root of 125? Again, what number times itself 3 times will give me this number inside of here? If I look at my perfect cubes, I know I have 125. I go backwards, that is 5. Okay. So that's kind of that gist there. Now, what if we had something that looked like this? This might get some of you all, so make sure we're paying close attention here. What if we have the cube root of 1 over 216? Okay. This right here is what will take some of you guys, and you'll kind of like, whoa, what's going on here? All right. So, like I've told you all in class, slow down, think about your process. Okay. So what we can do here is we're going to split the fraction. So basically what this is asking is, okay, we can split this fraction up and it'll look like this. The cube root of 1 over the cube root of 216. Okay, we can split this because it's asking for the cube root of the numerator and the denominator. Okay, so we got to look inside to see, do we have perfect cubes? And then our second step here is to solve numerator, I'm going to abbreviate, and denominator. Okay, so is 1 a perfect cube? Let's look at our list. Yes, it's 1. So I know the top part is going to be 1 over, is 216 a perfect cube? Look at our list. 216 is a perfect cube. It's 6. So the perfect cube of this would be 6, and our answer would be 1/6. Okay, so when you have a cube root of a fraction, you can split it, okay, and that'll help some of you guys kind of simplify this. So I split it, then I work the top. Remember how I talked about reading a book? Work top to bottom, okay? Work this out first, then work this out, and we would get 1/6, okay? So that's kind of our fraction there, all right? Now, another thing, we'll do this example right here, so we're on the same page. Cube roots can be negative, okay? They can be negative. So you remember with the square root, we cannot have a negative inside of the square root. With a cube root, we can. If I ask what's the cube root of negative 27, okay? Well, this might throw some of you off, but this can work, all right? So if we know 27 is a perfect cube, it's 3. So I know the cube root of 27 is 3. Well, it's a negative, it's going to be a negative 3. Just think of it like this. Negative 3 times negative 3 times negative 3. Well, what's negative 3 times negative 3? Positive 9, because a negative times a negative is a positive. Bring this down. 9 times negative 3, positive times a negative is a negative. 9 times 3 is 27. So the cube root of negative 27 is negative 3. Okay, that's just a little tip that these can be negative because it's times itself 3 times. If you do negative times a negative times a negative, you'll get a negative every time. Okay, so cube roots and cubes, perfect cubes. Hope this helps you guys. And if you have any questions, you all know how to get in touch with me. Hope you guys have a great day.